Hello everyone and welcome to this section. In this section we're going to look at the Jupyter Notebook and we're going to apply the perspective transformation that we have discussed previously. All right, so let's get started. So first of all, we load all our libraries, OpenCV, NumPy, and all that. And then here we're going to use an image, which is kind of showing the speed limit 25, and we're going to show the image. Let's run it, and that will actually going to show me my image. The key element or the key point that I wanted to cover here, which is I mentioned earlier, is that what I need is that I need this basically object kind of, like shift the perspective and actually make me face the actual object in an image, okay? So what I need to do is that I need to look at the source points, which is point 1, point 2, point 3, and point 4 manually, okay? That's kind of the issue here, okay? I actually have to go there and look for the indices basically of these points. Once I locate them, then I can apply the perspective transformation to actually apply the transform. Okay, let's get an idea. Okay, second point is we need to run simply load the image again and use what we call it plot.image_show. Why am I doing this? I'm doing this because here I'm showing all the pixels in the x-axis and the y-axis as well. Okay, why? Because once I know the number of pixels, then I can try to guess, for example, what this point is. Okay, I need to provide the x, I need to provide the y for each of the source points. Okay, I'm going to show you how can we get this. All right, let's get the dimensions. So here we're going to show the height and the width as well. And then here we're going to define, as I mentioned before, I want to define the source points and I wanted to define the destination points. Okay, all right. So let's take a look. Here I tried to summarize because it's a little bit confusing the order of what we actually provide the points. Okay. So the first entry is what we'll call it in the top left. So here you provide the top left. So we're going to provide this point first. And then I'm going to provide the second entry, which is going to be top right. So I'm going to provide again top right. So I'm going to provide this point. And then we're going to, in the third, we're going to provide bottom right. So bottom right, so we're going to provide this point. And then the last point, we're going to be bottom left. Again, bottom left. All right. So it's kind of you're rotating in a clockwise fashion. So you're going to provide point 1, 2, 3, and 4. Very simply. All right. So let's take a look. How can we get these points? Obviously, here I'm just provided the points, just for the matter of time. So first point is 260. Let's take a look if this is actually right or not. So we're going to go 200. That's the x direction. So actually, I moved here 200. Okay, that's good. And then I provided 60, okay? Key element here is the origin is actually in the top left. So this is the origin, okay? That's my origin. That's where I specify all the x and y. So from this point, I actually moved in the x direction 200, and then I went down to around, let's say 60 per se. Obviously, you can zoom in and make it a little bit better, but it worked for me. The second point is this point, which is again 450 and 150. Again, we're going to go in the x direction around 450, and then we're going to go down around, let's say, 150. Okay. Third point, again, we're going to provide the bottom right corner. Again, I'm going to move around 520, and then I'm going to go down to, let's say, 500, which is this point. And then the last point, we're going to be 170 and 470. Again, I moved in the x-axis 170 approximately. And then I went down to around 470, which is kind of here, around here. So here I provided the source points. And then afterwards, I need to provide the destination points. Obviously, I want the destination points to be kind of the size of my image, okay? So since I know the width and I know my height, what I could do is I can provide the top left corner, which is kind of 0, 0, which is simply the origin. And then I'm going to provide the next point, which is this point, which is going to be my width and 0. So, okay, so I'm going to do the width and 0 because it didn't go any further down. And then I'm going to provide this point, which is kind of width. And then I go down with all the height, which is kind of this height. And then I'm going to go from 0 to height, which is this point. Okay. Again, I didn't go any further in the x direction, but I went all in the y direction, which is 0 and height. Okay. And that's kind of the destination of the point. So basically, I need my image to be in the format of 600 and 800 per se. That's the dimension of the output image, which is the warped or the image that I can perform perspective transformation, or I've performed perspective transformation on. All right, let's run it. Looks good. And then afterwards, which is what I mentioned before, they're going to use what we call it get perspective transform, all right, and provide the source points, which is these points, and I'm going to provide the destination points, which is my destination image or location of the size of the image that I wanted. And then I'm going to get the transformation matrix. I'm going to use the transformation matrix along with the image, along with what we call it warp perspective. And I'm going to provide as well the dimensions of the output image, which is kind of the width and the height. That will give me the warped image. You're going to plot the warped image, and that's pretty much it. Let's run it, and that's it. Looks great. So the size of the image is again 600 by 800, and that's how you actually can face the image. And then you can see how can we perform a lot of operations. We can do Gaussian, for example, noise removal. We can make it like more sharp. We can increase the contrast. Then we can use what we call it dilation and erosion. We're going to cover that later. How can we actually make these letters more thick, for example, or maybe eroded, for instance. That's how you do all the image manipulations. So, you know, like machine learning and deep learning algorithms can actually look at it and classify it with a high accuracy. All right. Okay. That's pretty much all I have for this section. I hope you guys enjoyed it, and see you in the next section.